I am quite sure that you have already thought about the winds and the convergence and the rising air and precipitation, sinking air, high pressure, no clouds, no rain, and think that must somehow be related to where the forests are, where the deserts are, and so on, right? So, of course, you are right. They have to be related to each other. So, let's try to understand that a little bit. Again, these are just simple introductions. If you want more details, if you're old enough to seek more details, there are lots of podcasts on my website, on my in my channels as well. So, let's not bother with the idealized Earth. In the sense, what are we idealizing? Basically, we are saying that there are no lands, the entire planet is covered with the water, so sea level is so high that all the land is underwater and even the mountains have somehow been put underwater. We call this the aqua planet. Remember that we said the ITCZ has this complicated pattern that is related to having lands, right? Because why? You already know the answer. Because land has low heat capacity, warms faster, cools faster than the oceans. But if you imagine that the entire thing was underwater, then entire thing will have the same heat capacity. Then you will not have too many such complicated migrations of the convergence zone with the sun. You will have more uniform movement back and north. That's why you do idealized Earth and normal Earth. So here is the idealized Earth and the actual Earth. Only thing you want to remember here is that wherever there is a convergence of winds like the northeasterlies and southeasterlies, you create the intertropical convergence zone, which in this case is sitting on the equator, and then you have the air sinking here in the middle because westerlies are going this way and the northeast trades are going this way. When winds are going away, then new wind has to come down. That is the sinking, called subsidence or divergence. So near the surface you have convergence winds coming together. Here you have winds going away. It's called divergence. Okay, just remember as best as you can. Similarly, polar easterlies are going to meet the westerlies, which are from the west, mostly towards the northeast, but nonetheless they come together. And what do you expect? You expect that there is also convergence and precipitation here. We can keep saying rainfall here because it's mostly water that's falling other than the hail or the snow in the mountains like the Himalayas. But here we say precipitation because at these cold latitudes you expect that it's going to be more complicated than just water. There is a lot of snow on land as well here at the surface, not just on the mountains, right? In the actual world, on the actual Earth, obviously we have complicated land distribution, complicated ITCZ, which we are still not showing here, but we are putting the winds and we are showing the rising air, the warm air coming together with the winds, northeasterly and southeasterly trades. We said the rising air hits the ceiling and goes towards the north, sinks somewhere and comes back. So this is a cell. We called it the Hadley cell, and where there is divergence, warmer air is going north, colder air is coming south and sinking. So there is sinking on this side, sinking on this side, so you have divergence, high pressure, which is called subtropical high. Remember, these were called the doldrums, where the winds are weak because winds are coming together and going to zero approximately. So we have the Hadley cell here, we have the Ferrel cell here, which is going in this direction, Hadley cell is going in this direction, and we have the polar cell, which is again going in this direction. And note here that it's all cold, it's all blue arrows. You had red arrows and blue arrows, red arrows and blue arrows. Here you have blue arrows, cold air. Sinking again here because from both sides you are meeting, and high pressure. Polar high means very high pressure. Okay, so that's what gives you the distribution of precipitation, which is mainly in this band here and mainly in this band here. But you already know that this is not exact in the sense that it is a bit more complicated like this. So you just remember those sorts of things. The main thing you want to remember is that the ITCZ and the precipitation are very closely related to the winds, and the winds also are related to the surface temperatures, not only on land but also on the ocean, but much more so on the ocean, because the ocean moves around, is deep, has high heat capacity, warms slowly, cools slowly, and so on. So we'll look at animation of the temperatures, of the rainfall and precipitation, of the winds, and so on in the next podcasts. Okay, so this gives you a sense. What else do you have to do? Basically, you have to remember, if the winds are converging and there is rain, then winds are diverging and there is no rain and high pressure. That means those regions don't get rain, which means they will be dry, and sometimes so dry that they are deserts. Okay, so that's what we are looking at here. Again, this is supposed to be an animation. We are here. So this is something called chlorophyll, which is measured by a satellite. A satellite goes up, looks at all the light coming from the earth in a certain band where chlorophyll function. Plants take light, CO2 and water from the roots, and they photosynthesize, right? For photosynthesis you need plastids or chlorophyll. Why the green, why the leaves look green? Because they have chlorophyll. Similarly, in the ocean you have phytoplankton. Plankton are drifters. They don't swim so well, they move with the currents, but they have chlorophyll. So when they get light, they have water they're in the water. They need other nutrients like fertilizers. They need nitrate and ammonium and all these good things, and they also photosynthesize. So you see green colors in the ocean as well. What is the beauty of this figure? I don't know if I can do this animation again. Here we go. So you can see high latitudes have very little photosynthesis, but even then you see some colors here. The scale of the colors is when there is dark green, there is a lot of vegetation, lot of photosynthesis. When it's dark blue, it's plain ocean, not much photosynthesis. Similarly, on land you have brownish colors, which means no vegetation, so it's basically deserts. So obviously, where there is air sinking, where the Hadley cell sinks and the Ferrel cell sinks as well, you have deserts. Not only on land, this is the amazing thing, you have deserts in the ocean as well. In the ocean, where there is no chlorophyll near the surface, very little photosynthesis, that is the ocean desert. And you can see that the ocean deserts are lined up with the land deserts, and sometimes they are tilted a little bit because the ITCZ was tilted. Again, that's because the land distribution is uneven. There is land here, the Gulf of Mexico is here, which is a little bit warm, and this is of course Sahara deserts, the Middle East. And why isn't the desert going this way? Shouldn't it go this way? Well, you already saw that. You saw that the ITCZ goes way north here. So desert here, sinking air to the north here, desert also here in some parts, and of course you have desert in the Middle East going into Mongolia. Why does it go this way? Because ITCZ is pulled way north because of the South Asian monsoon and the East Asian monsoon, also called Indian monsoon or South Asian monsoon, which means we have been lucky in India because we could have been a desert instead. We are lucky. We got all this rain and I hope you computed the amount of water that falls during the monsoon. As I said, take the average rainfall during the monsoon, take the area of India, multiply it, look at the average volume or storage in a bucket and compute how many buckets there are. I will give you the answer. There is about 200 lakh crore buckets of water falling during the summer. That's 2 lakh buckets per person. Are you saving the 2 lakh buckets you are getting during the monsoon and using it well? That's what you have to think about. Okay, so now we very cutely related the winds, rising winds, sinking winds, low pressure, high pressure, precipitation, dry regions and deserts, in the ocean, on land, rainforests where there is a lot of rain, and Western Ghats can be seen here, Himalayas, a lot of rain here in Thailand, Malaysia, Borneo, Southeast Asia, Indonesia and New Guinea and so on and so forth, and large deserts here and lots of Amazon and the dry region here next to the Andes, and desert, Namib desert over here, and of course more complicated issues here. Okay, so you can stare at these for a long time and you can see that there are seasons. There is explosion of red colors here, which means a lot of photosynthesis happens when sun comes up and there is enough light. Remember, photosynthesis needs light, CO2 and of course all the nutrients. So these regions, they are blowing up in spring months when the sun comes north and there is enough nutrient available, enough light available, and so on and so forth. This is a beautiful image that shows vegetation in the ocean or photosynthesis in the ocean, photosynthesis on land. You can keep on looking at it and you can see that where there are rivers there are a lot of red colors. Is that all photosynthesis? Not necessarily, because a lot of the rivers are bringing a lot of so-called organic matter, like you can see here in the Mediterranean. Mediterranean is here, is the North Sea and so on and so forth. Black Sea and coasts here. You can see the Congo Zaire river coming out. You will see the Amazon coming out here as well. The red colors, the Ganga, Brahmaputra, Krishna, Mahanadi, everybody coming out. Some rivers coming out here and so on and so forth. Okay, so rivers bring organic matter which also has chlorophyll, so or some colors that reflect in this or radiate in the same band of wavelengths that the satellite sees. So sometimes it mixes chlorophyll with other organic matter. They're called colored dissolved organic matter, CDOM, if you want to look it up further, and so on and so forth. Okay, so exciting figure and very informative figure as well. So I started with a water cycle. I ended up with vegetation, deserts, because they are closely related. Water cycle cannot be talked about without talking about precipitation, and precipitation cannot be talked about without vegetation, and vegetation cannot be talked about without deserts. And so hopefully you learned something new, that even oceans have deserts. But fish can move around just like birds can fly around on land, and there are things living even in the desert. There are snakes and scorpions and some kind of insects and dung beetles and so on, and camels can live there, and people of course live there, and so on and so forth. So this interaction between rain, winds, deserts, vegetation, this is what makes the earth system, right? So we talked about that before. So bring all these things together in your mind, because as you want to become earth system expert, and maybe you become an earth system doctor, because you will figure out what's wrong with the earth system, what are we doing to the earth system, and you will find solutions, you will prescribe medication, you will heal the earth system. So imagine one day you will become earth system doctor. Okay, so let's meet in the next chapter, look at some animations, but first we'll look at the carbon cycle. We'll only look at one elemental cycle, and that will be the carbon cycle. Okay, see you next section, next podcast on carbon cycle.